Okay, greetings. Welcome to this class. So today we will get started with transmission. So we were looking at IC engines. So if we look at the overall automotive powertrain, we could realize it in as a few blocks. The first block is the so-called prime mover. So we have looked at the internal combustion engine. So I am abbreviating as ICE. So that is a very common prime mover. So one can also have an electric motor as a prime mover in electric vehicles. One could also have a combination of them, IC engine and electric motor as two prime movers. So the prime mover delivers some torque, let us say we call it as some Tp at some, let us say, speed omega p. Okay. So let us say I put it as Tpm omega pm. Okay. So the prime mover delivers some torque T subscript pm at some speed omega pm, and it provides this torque to what is called as the transmission. The term transmission, by and large, like in the automotive domain, is used to represent one element in the overall powertrain, and typically the what is called as a primary gearbox is what is referred to as the transmission. So we are going to define these terms more carefully shortly. So the torque gets multiplied in the transmission by the gear ratio, and the primary gearbox delivers some torque, let us say T subscript T at some speed omega subscript T, which then goes to what is called as a final drive. So we look at all these blocks in this module. So a final drive, like a differential unit, right? So typically will split the torque that is coming out of the gearbox and provide it to the wheels. Suppose let us say the a vehicle is such that the front wheels are driven. So the final drive will split the torque that is coming out of the gearbox and provide the torque to both the left and the right wheels. So that is what the final drive will do, and this delivers some torque T at a speed of omega d. This is ultimately provided to the wheels, and the wheels through their contact between the tire and the road interface generate a traction force F, and the vehicle moves at some speed V. Okay. So ultimately this is the flow of energy transfer through this system. Okay. So this force F is what is called as tractive force. Okay. The entire set of components from the prime mover to the wheels is what is called as a powertrain. So let us write down a few definitions. The first term is powertrain. So the term powertrain essentially refers to the prime mover, which can be engine or an electric motor or a combination of them, and the drive line that transmits energy to the wheel. Okay, that is a powertrain. Now, if we leave out the prime mover, what are the components that are left behind in the powertrain? They constitute what is called as a drive line. So, the term drive line includes all the components excluding the prime mover, okay, in the powertrain. So, includes all the components from the prime mover, but not including the prime mover, okay, to the wheels. So, that is the definition of drive line, okay. And the term transmission is typically used to refer to one unit in the drive line and by and large it is the primary gearbox. Okay, so these are the definitions. So, if you look at it from a macroscopic viewpoint, we are going to look at the entire powertrain per se, right? But in this module we are going to focus mainly on the transmission, okay. And once we learn about transmissions, we will learn how to combine an engine and a transmission and achieve certain vehicle performance requirements. So, that in broad is what is called as transmission matching or powertrain matching, okay. So, that is an analysis which we will do. But before we look at transmissions, let us first reason out what are all the expectations from an automotive powertrain, right. Then we will be able to better understand what the current powertrain provides and why the transmission is realized the way it is currently, okay. So, because if you look at most vehicles today, right, that are powered by IC engines, so we will have a multi-speed gearbox, right, which the driver controls to get the output from the powertrain. So, what is the reason for that, right, and how does one choose those gears, right. So, those are questions which are important for us to understand. So, to answer those questions, first let us understand what are the expectations from an automotive powertrain. So, let us list down what are all the requirements from an automotive powertrain, okay. So, the first requirement is that it should transmit energy required for propelling the vehicle, okay, and this energy should come from the prime mover and transmitted to the wheels. So, that is an important requirement of an automotive powertrain. Another important requirement which we by and large experience when we start a car and then like we want to move, is that like one of the important requirements is that like when the car is started, we have to enable the car to be moved from rest, and that's something which an automotive powertrain should provide for. Okay. So the powertrain should ensure that the vehicle, or should enable the vehicle to move from rest. So that's another important requirement of an automotive powertrain. And the powertrain also should adjust the torque and the speed or the force output coming out from it which is available to propel the vehicle, such that the requirements of various operating conditions are met. See, for example, let us say a car starts from rest, we would require high force to propel it because we need to overcome inertia and move the car to a certain speed at a certain acceleration. And let us say a car is cruising on a flat road at a high speed, still we may need to overcome some resistances and enable the car to cruise at that speed. So that the level of forces or tractive force that will be required in that scenario would be different from the first case. In another scenario, let us say a car is going on a flyover, right, or on a hilly terrain. So we have to essentially go up on a grade. So then the vehicle should be able to overcome the corresponding resistances and ensure that the car can move up the grade at some speed. So under each scenario, the requirements that are expected out of a powertrain would be different. So the powertrain should adjust the torque and speed depending on the operating conditions. So that is a very important requirement of a powertrain. So the output from the powertrain should be automatically adjusted, depending on the requirements of the vehicle. Okay. And as a vehicle designer, we would also have some expectations of the powertrain, right. So let us say a vehicle designer comes to a powertrain designer. The vehicle designer may want the powertrain designer to design the powertrains for the particular vehicle to meet some expectations. What can be these expectations? They can be certain specifications in terms of what is the maximum acceleration that the vehicle should achieve. That is like, let us say 0 to x kilometers per hour in y seconds. That is a specification, right, isn't it? And what should be the maximum longitudinal speed at which the vehicle should travel. So someone may say, hey, the car that you are designing should be able to travel at a maximum longitudinal speed of, let us say 160 kilometers per hour. That is an expectation. Someone may say, I want my car to climb a grade with a gradability of, let us say 20%. So we will see what that gradability means, right. So once again we are stating our expectations. And someone may say, I want my powertrain when essentially installed along with the car and operated on a particular driving cycle, right, or driving pattern, should provide me with so much of fuel economy. That is a fair expectation, right, in terms of mileage and fuel consumption and so on. So the question is, how do we convert those expectations into ratings of the powertrain components? So that is also a job of a powertrain designer, right. So a powertrain should enable the realization of vehicle specifications such as maximum acceleration, maximum longitudinal speed, gradability. We are going to look at all these specifications as we go and do when we do transmission matching, fuel economy, range, etc. So, range becomes important because nowadays with growing emphasis on electric and hybrid vehicles, right, one would want to say, hey, what is the distance that I can travel before I have to recharge my batteries, right. So, essentially range becomes an important specification. So, one may basically inform the powertrain designer that design the powertrain such that the range of the vehicle is 200 kilometers. So, the battery has to last 200 kilometers in a single charge, right. So, that is a expectation. So, given these expectations, what are the ideal characteristics of a prime mover which would be desirable? So, if we plot the torque and power of a prime mover with a speed, an ideal prime mover should be one which provides a constant power across all speeds, and since power equals torque times omega, the torque profile would be a hyperbola, right. So, if the power were constant, torque will be some constant divided by omega. So, this will be the torque requirement. And how can we reason it out? So, suppose if I am at low speeds, my vehicle is starting from rest or going at low speeds, the main resistance that I would want to overcome when I start from rest is the inertia of the vehicle, m times a. So, there I require more torque, correct. And even if I am driving my vehicle on a gradient at low speeds, let us say 15 kilometers per hour or 20 kilometers per hour, if the slope of the gradient is, the angle of the gradient is, let us say some theta, I need to overcome mg sin theta, right. So, that also typically turns out to be a significant number. So, when we are operating at low speeds, we would require high torque, okay, from the powertrain, and speed keeps on increasing. Let us say we go to high speeds, let us say we are going on a highway and driving at let us say 100 kilometers per hour. We would see that the resistance forces that are going to come and which need to be overcome by the powertrain, the magnitude of the resistance forces will drop down. There are going to be resistance forces, we will identify what those resistance forces are when we do the analysis, but their magnitude is not going to be as high as at low speeds. So, we need progressively lower forces as we go along. So, that is why at low speeds we require a high torque, and as speed increases the torque requirement decreases.